1, this video would focus on writing formula that expresses an inverse relationship, or pretty much changing an inverse proportion statement to its equivalent equation. Before we go farther, please feel free to check out the description below for the link of the other series of topics related to inverse variation. Before we go over this example we have right here, let's have a review on the basics of inverse variation. So what is inverse variation? To better understand this type of variation, let's look at variable A and variable B. For inverse variation, if variable A increases, variable B will decrease. Now notice the direction of the arrow. The other one goes up while the other variable goes down. On the other hand, if variable A decreases, then variable B will increase. And again, notice the direction of the arrow. The direction of the arrow goes in opposite direction. And that is what we mean by inverse variation. So whenever we see two variables are inversely proportional with each other, we can say that A varies inversely as B, or A is inversely proportional to B. Now let's look at some real-life examples of inverse variation. Speed and time are inversely proportional to each other, which means that if a car moves at a faster speed, then it takes less time to get to its destination. On the other hand, if a car moves at a slower speed, then it takes more time to get to the same destination. And that makes speed and time inversely proportional to each other. Now let's look at another example. Number of trees and air pollution on a given area are inversely proportional to each other, which means that if the area has a greater number of trees, or if it has more trees, then it has less pollution. On the other hand, if that same area has less number of trees, then it will have a more probability of getting air pollution. And so again, these two are inversely proportional to each other. Now let's look at another example. Practice and number of mistakes are inversely proportional to each other, which means that the more we practice, the less mistakes we commit. On the other hand, the less we practice, the more mistakes, or we get more probability of committing mistakes if we have less practice. So these two are inversely proportional to each other. We also remember that the general equation for an inverse variation is y equals k over x, where our k is called the proportionality constant, so that we can go ahead and say that if we wanted to determine the constant of variation, or the proportionality constant k for an inverse variation, we go ahead and we can rearrange this equation as k equals xy. Okay, going back here, let's go over the first example. T varies inversely as x. Now we remember that the general equation for inverse variation is y equals k over x. So in this case right here, we have t varies inversely as x. So I can go ahead and write t equals k over x. So this is the equivalent equation for this statement right here. Now let's move on to the next example. Okay, in the next example, we have E varies inversely as W. So again, the general equation for inverse variation is y equals k over x. So in this case right here, that would be E equals k over W. So this is the equation that is equivalent to this statement that we have up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the general equation for an inverse variation is y equals k over x. So the statement that we have here is V is inversely proportional to T. So I can go ahead and write V equals K over T. So this is the equation for this statement that we have up there. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. Okay, so we go over the problem here. The statement says R is inversely proportional to Q. Again, we remember that the general equation inverse variation is Y equals K over X. So the equation that would work for this would be R equals K over Q. So this is the equation for this statement that we have up there. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!